The purpose of this question is to help a company decide whether or not they should use a new technique to make a component. They test 120 components made with the new technique and 240 with the technique they currently use. At the end of 250 hours of use, they check the components and record whether they have no cracks, minor cracks, or major cracks. The data from the trial are given in the table. In total, 141 components had no cracks. Question AI shows that the value of A is 53, 1 mark, and then find the value of B, also 1 mark. So it's quite clear that A can be found as what, 141 minus 88, and it's 53. And then B can be found as what, 120 minus 53 minus 54, and it's 13. The next. One of the components from the trial is selected at random. Question B. Given that this component had minor cracks, find the probability that it was produced by the new technique, 2 marks. And you remember, if you meet a given, it's about what? It's about conditional probability, and we need to write the question correctly. So we need probability of what? Probability it was produced by the new technique. So we need probability of new given what? Given minor. And you remember formula, it's a probability of and, so new and minor, divided by probability of given, so probability of minor. And in terms of probability, it becomes what? New and minor. It's 54 out of, or divided by the grand total, but the denominator it also will be something divided by this grand total, and this grand total just cancels. So finally we can write it as what? New and minor, it's 54 out of a minor. Total minor, it's this value, which is the sum, 54 plus 96, and it's 54 divided by 150, or 0.66, and definitely it can be found, the grand total can be easily found. It's what? It's just 360 if it's required. 136. The next. C. A chi-square test for independence is performed at a 5% significance level to determine whether a component having no cracks, minor cracks, or major cracks is independent of the population technique used. And I state the null and alternative hypothesis, 1 mark. You remember that the null hypothesis it's when something are independent and alternative are not independent. You may just rewrite as it is given in a question, or write a bit different, for example like this, that's the development of cracks and the technique used are independent. And hence the alternative, you rewrite the same. The development of cracks and the technique used are not independent. Then find the p-value, and then find the p-value 2 marks, and then state the conclusion of the test in context, justifying your answer, also 2 marks. And test for independence, we use what? Matrices, and we choose edit matrix A, and we just enter these values, you can see, and then tests, and we need just chi-squared, not this but this, and you can see observed A, expected. In general, you may be asked to find some expected values. You can get some expected value from matrix B, but you remember that expected can be calculated as total row multiplied by total column divided by the grand total. And you remember, if expected is less than 5, you should combine some columns or rows in general. So you can see that p-value is this, and then as usual, so p-value is equal to p-value is 0.0170, and then the conclusion, as usual, we compare with the significance level, and it's less than 0.05, and what we reject H0 or accept H1, and in the context we write that there is sufficient evidence to suggest, it's not necessary to write to suggest, that the development of cracks and the technique used are not independent. And if you need observed values, you need just matrix B, and you just choose matrix names B, and you get the expected values. Not observed, because observed are these values, and expected are in matrix B. The next, D. For the components in the trials that were made with the current technique, shows that the proportion which developed cracks is 19/30, 1 mark. Current and with cracks, you can see, so proportion or probabilities, it's just 96 plus 56 divided by 240. And it's 152 divided by 240, and it's 19/30 as required. The next, as an alternative measure, the researchers decide to let P be the probability that a component made with the new technique develops cracks. They then test the following hypothesis. I0 is that proportion is 19/13. It's obtained from the current technique, and the alternative that this proportion has decreased it's actually given. So in a randomly selected sample of 120 components made with the new technique, it's this new technique. Let capital X be the number which developed cracks. The researchers assume that under the null hypothesis, is that x is distributed binomially with parameters 120, 19 over 30, and question E, state one additional assumption that the researchers are making in choosing this distribution. One, you remember that for binomial, constant probability, fixed number of trials, independent events. But I would answer, for example, that the probability assumption is that the probability that a component to have a crack is constant. But I'll write what is given in a mark scheme. It's actually the same. It's about independence. So the probability of each component developing cracks is independent of all other components in the sample. It's about what? It's about that events are independent, so events that we get a component with a crack is independent of another component. And actually it's also related to constant probability, but this is given in a mark scheme directly like this. I just rewrite this. And the next F, use appropriate data from the trial to perform the test proposed by the researchers at the 5% significance level. State the conclusion of the test, justify your answer, 5 marks. And as usual, since we test for p becomes less, so we should consider probability x is less or equal than some experimental value, or it's called test statistic obtained from some sampling or experiment. And it's about what? It's about new technique, and we consider what components with cracks, and it's 67. So this test statistic or some experimental value which should be used at 67, and we need just calculate probability. And if it would be probability greater to be the alternative, we should consider greater or equal than 67, and we need just calculate this probability under this binomial distribution. It's quite easy. Since it's less or equal, we use binomial CDF, or you may use, if a calculator allows that a lower bound to be 67, upper to be 120. So it's quite easy, and we need distributions and binomial CDF, not PDF. PDF it's when x is one value, some specific value. CDF less or equal. Trials 120, probability 19 over 30, x value 67, and just enter, and we get the probability 0.0549, and it's a p value. And then, as usual, we compare it with the significance level. It's 5%, so we can see that it's greater than 5%. And a conclusion, so we accept H0 or reject H1. And in the context, there is there is insufficient evidence that the new technique reduces the number of cracks. The next G, in comparison with the test in part C, it's about independence, test for independence, chi-square test for independence. State 1, mathematical reason why the test in part F, it's this for proportion, might be preferred. It can be preferred. Why? For example, because it's a directional test. What does it mean? It means that we test that proportion has reduced, not in general. For independence, it's just that something is independent or not independent, and it's a benefit of this method. So we can say the next that the test for proportion is directional, and so considers whether the new treatment reduces, not just changes or independent, but exactly reduces the number of components developing cracks. And the next the test in part F, again the same for proportion, binomial, might not be preferred. Also 1 mark. Not preferred. You can notice that we get P, this proportion from some sample, and if you choose another sample, there will be another value of P. So we can say that there could be variation in the value of P. Chosen for the null hypothesis, or you may just say that P cannot be constant or something like that, or if we choose another sample P will be another, or the test has to make an additional assumption, for example for independence, or additional assumption for constant probability. Or you may write maybe just the test has to make an assumption, maybe enough the test, but I just rewrite directly like it is given in a mark scheme. The test has to make an additional assumption for independence. And the next. For these components, the researchers also consider the mean time taken until cracks develop. It is hoped that using the new technique will increase this value. A second trial is carried out and the times in hours taken for cracks to appear is recorded. The mean time taken for cracks to appear, it's this value t hat, and the value of s of n minus 1 for each technique are given in the following table. H. Perform an appropriate test at 5% significance level to determine whether the new technique increases the mean time taken for cracks to appear, 7 marks. So it will be what? Two sample t-tests. First of all, why t? Because variance is not given or standard deviation is not given. It is estimated from the sample, so it will be t-test. And you may write null and the alternative hypothesis in words, or you may write what is mu values, what do they mean, and then just write the null and the alternative just in terms of mu. So let denote, so let mu1 be the population, and actually it's a test to compare population means, and it's very important to emphasize that it's about population means. Let mu1 be the population mean length of time before cracks appear with new technique, and then mu2 be actually the same, the population mean length of time before cracks appear with current technique, with current technique. Hence, the null hypothesis becomes that mu1 is mu2, no change, and as the alternative it becomes mu1 is greater. Why greater? Because mu1 is new according to for new technique, and we test whether the new using the new technique mean time has increased. Or in words, you may write like this, for example, H0, the population mean length of time before cracks appear is the same for both groups. Or you may write for current new technique, something like that. And the alternative, the new technique increases the population mean length of time before cracks appear. And so let's perform this test. So stat tests, and we need two sample t-tests, this and stats, and it's mean for the first, it's 250.1, and as x1 it's exactly as n minus 1, not Sn, because Sn minus 1 it's unbiased estimated for population standard deviation, and if you calculate just Sn, it's just for the sample, and for the calculator we need this S, it implies Sn minus 1. There is a formula in the data booklet, and if it is given just standard deviation for the sample, it can be calculated this as n minus 1. So for the first is 3.8. It's new, yes, it's correct. It's the first is for new, and n is what? It's 100. It's 100. So the mean for the second is 249.1, 3.8, and n2 is what? 200. And we need mu1 to be greater. It's this one. It's already chosen and always pulled. It all for problems it will be pulled, and just calculate. And you can see that we get the required p-value. Let's check. Let me check. 0.0162. Yes, it's correct. So p-value becomes 0.0162, and then as usual we compare it with the significance level, so it's less than 0.05, and conclusion, so we reject H0. And what does it mean? There is sufficient evidence to suggest that the new technique increases the mean length of time before the cracks appear. And the last question. The company decides to go ahead with the new technique and published the following statement: statistical tests show the new technique will significantly increase the time before components crack and need to be replaced. Comment on this statement. 1 mark. So first of all, that the significance of the test, it means the sufficient evidence to to accept the alternative hypothesis. It doesn't imply the significance change in mean values. And actually you can see that we compare very small difference. so difference is 1 over 250, which is not significant. And we can answer the next. You may answer something like the significance of a test, or how to say that the acceptance of the alternative hypothesis doesn't imply the significant change in mean values, something like that. Or according to the test, we compare the difference, which is approximately only 1 over 250, which is not significant difference, something like that. Or I'll just rewrite what is given in the mark scheme. So the minimum time, not mean time, before cracks appear should be considered given the context. It means that it would be better to compare not mean times before not what it is considered that mean time, mean length of time before the cracks appear, and it would be better to consider a time when the first crack appears. So for example, it may be one of variants how to answer. So the minimum time, not mean time, before cracks appear should be considered given the context. Or it would be much better to consider or to compare what confidence intervals, and confidence interval gives what, some mean value plus some interval. It's like something plus minus something, and it would be better to compare here. It would be we will compare two mean times, but it will be more clear and more appropriate. And actually we will compare, for example, 250, for example, and 248, for example, something like that, and then we can conclude that difference, or it may be like this, 250, for example, plus 5 and plus 4, something like that, and hence we can conclude that difference is not significant, something like that. So we can say that it would be better, or an appropriate confidence intervals should be considered and not simply means. And that's all for this question.